Welcome back to our hierarchy of quadrilaterals. Quick review on what we've talked about already. We started with our quadrilateral. Quad means 4, so it's a 4-sided polygon. The sum of the interior angles is 360 degrees. Getting more specific, we move into our trapezoid. Our trapezoid has one pair of parallel sides. A more specific trapezoid is the isosceles trapezoid. Isosceles means the legs are congruent, so we have two congruent legs, and the common base angles are congruent. So we have two pairs of common base angles, those are congruent. Also, our diagonals spanning across that quadrilateral are congruent, and the adjacent angles, not along the same base, are supplementary. So those two and these two. Also note that if you draw a mid-segment on your trapezoid, then that mid-segment is parallel to the two bases, and its measure is two bases added together divided by 2. Our next order was our parallelogram. Remember, our parallelogram has two pairs of opposite sides that are both parallel and congruent. Parallel and they're congruent. The opposite angles of a parallelogram are congruent. And all adjacent angles, remember, sup. This one is sup, this one's sup, this one's sup, this one's sup. And our diagonals bisect each other. So the distance to where they meet is equal going in both directions. Distance to the middle, equal. Today we are going to move on to talk about a more specific parallelogram, the rhombus. So our rhombus is pretty special because for this parallelogram, not only are the opposite sides parallel with each other, not only are the opposite sides congruent, they're all congruent. So all of these sides are congruent. Our second property talks about our diagonals. So again, we're going to sketch in diagonals into our rhombus. And the diagonals are going to bisect our opposite angles. So diags bisect opposite angles. That means that this angle is split in half. So those two parts are congruent. This angle is split in half. So not only are these two angles congruent, but now all 4 of these parts are congruent. And then again, going with this angle, split right in half. So not only are those two angles congruent, the whole angle, but now each of these parts is congruent too. In addition, this perpendicular bisector is meeting up with the other one right in the middle. Again, going back to our idea of parallelograms, diags bisect each other. Our sides will be bisected. And in the middle, where they meet, they are actually meeting at a right angle. So that makes our diagonals perpendicular bisectors. And remembering back to that idea of what perpendicular bisectors means, the idea of perpendicular is meaning that where they are intersecting is going to form a right angle. Bisector means split in half. So it's splitting these diagonals in half, forming a right angle. So what happens when all three, or where our perpendicular bisectors intersect, makes those right angles? What is formed? Well, it looks like we've got a right triangle here, right triangle here, right triangle here, and another right triangle. So the diagonals form 4 right triangles. And that's our fourth and final property of our rhombus. All the sides on a rhombus are congruent. The diagonals are bisecting the opposite angles, splitting those angles right in half. The diagonals are perpendicular bisectors, which means not only are they splitting those diagonals perfectly in half, but they are forming right angles. And those diagonals then are forming 4 right triangles because each of these angles is 90 degrees. So you have 1, 2, 3, 4 right triangles. Awesome. I will see you next time to learn about some rectangles.